wouldn't need to know the hardware specification. You wouldn't need to know about the OS layer. So if you have a proper Docker image, you can run it anywhere. So I highly encourage developers to look at what Docker is, what containers are, what is Kubernetes.
And I have been through it myself. I've personally been a software developer. I have done the same exact thing. You go to the server, you download the last version because you've lost of track what versions that you have. Then you make the changes and then you re-upload.
Yeah.
And anything goes wrong in between, good luck.
Hopefully this is no longer the case.
Hello everyone and welcome to a new exciting episode of Digital Transformation Podcast, which would be in English. And this is our first English episode that we will be doing. Today I'm very, very excited to host a very special and talented team leaders here at DIT, which we will be talking about how we can transform the legacy-based system into DevOps operations. And talking about DevOps, I don't really want to describe it and then talk about technicality, which is not my specialty. I'm very, very excited to introduce today's guest with us. Today we have Shkar, the head of DevOps at DIT. Shkar, welcome.
Thank you very much, Kakadawar.
I'm very, very excited to be here with you.
Pleasure is mine. Thank you very much.
As normal, I don't want to talk about you. I don't want to introduce you. I want to leave the ground for you. Just talk to us a little bit about yourself.
Course. I'm Shkar, head of DevOps here at DIT KIG. I am leading the DevOps team of 3 people currently. And we take care of the day-to-day operations of automating, deploying, and monitoring the software that is developed by the dev team.
Yeah, I'm very excited to know more since the DevOps has enriched the team to be able to perform outside the normal capabilities. And before getting to the technicalities, let us know and talk to us about your exposure, your touch with DevOps. How did it start? When did it start? And talk to us a little bit more about specifically your role at DIT.
Yeah, of course. So I actually come from a different background than computer science. I'm an electrical engineer, studied at the University of Sulaimani. I've been doing software as a hobby for some time now. So it was not my main education piece. But I've been doing software for about 7-8 years now. And I transitioned to more of an automations and DevOps role around 4-5 years ago, let's say. So I was initially doing software, then I transformed into doing DevOps.
Yeah, I'm very curious to know what technologies previously used to have. Which programming language and framework used to work on?
I started out with Lua. It's a language, an interpreted language on C++. Then I started doing a little bit of PHP. Then I started the usual route with Java, C#, and I stayed on C# for quite some time, and I still do that as well. Nowadays, I do some Go, I do some TypeScript, but my main day-to-day operations are on C#.
Yeah, amazing. Very glad to know more about your background because just jumping up to DevOps would definitely require previous prerequisites.
Yeah, definitely.
Yeah. So, still about your role at DIT. When really did you join DIT and how was it? Just talk to us about the journey.
Yeah, so actually, how I joined DIT was kind of a coincidence. I was not planning to do that. I had just left my previous job because I wanted to take a break. I wanted to travel a bit. And I had actually planned to move to Hawler, but I'm originally from Suli. But DIT was not in my list, let's say. I got contacted by one of the recruiters here, Kak Bruce. He's still with us. And we got to talking about the technology and the great job that the team here is doing. A very small team at the time, of only 4 people, if I'm not mistaken. Then I saw potential of my skill set to be an improvement to such an important department to drive to the goals that the department has. So that's when it was around 1st of April on 2021.
Nice.
It was right after the coronavirus quarantine.
Yeah, yes. Your journey has been a bit quite different. The moment you said I was not planned and then I joined, that's something very interesting.
Yeah.
Yeah, because mostly the job market, people prepare to a specific job and they
Exactly.
try
Yeah.
to craft their skills and then in order to
Definitely.
be yeah, very, very amazing. So that was quite a understanding about you and your background with the IT. And now it's time to dive in a little bit of the real deal, the real topic that we want to talk about, and it's about DevOps.
Definitely.
But before I ask a formal and a kind of serious documentation style definition, I really want you to talk to us what DevOps means to you.
Yeah. So to me, DevOps is about making developers' lives easier. That is always my go-to, let's say, description of DevOps. It's just to make sure the dev team, the operations team work closely together so that the dev team do not have to go through so much hassle. Make sure they have enough tools at their disposal. Make sure they have enough automations at their disposal so that they can focus on what really matters, which is the business logic, which is the implementation detail, technical implementation details of software that's being developed.
Yeah, interesting. So, and then there is a term. Let's say there is a word that really comes with DevOps, which is called methodologies.
Yeah.
Could you just talk to us about what does this word exactly mean?
So the methodologies really are just practices that you apply to your organization or department. They contain things like making sure you plan, you test, you develop, you deploy, you test again, you operate, monitor, and then you come back to the drawing board, plan again for next iteration. So it's that whole software lifecycle that starts basically from planning the software, the BRDs, the business requirement documents for that software, into developing that software, writing automated tests for it, deploying it continuously, and testing it continuously. And at later stages, you have enough observability into that software that you can make key decisions about what to improve, what to look at, and what not.
Nice. So that's quite brilliant. But I'm curious to know what would be the opposite of DevOps methodologies. I mean, if we think of a system that does not apply DevOps methodologies, what that system would be, and even what does it mean? What's the naming to it?
So, as previously mentioned, it's all about practices. And one of the main practices of DevOps is making sure things are autonomous. Basically, you wouldn't, in a legacy-based system where DevOps practices
So it's called legacy, right?
I mean, there isn't really a word for it. It's just not applying the practices, right? Not to my knowledge anyways. But it's just not applying those practices, making your life harder. Would be, for example, not automating the process of building, testing, and deploying software. If you don't do those things and you are not, let's say you're not on par with technology these days, you are usually a little bit behind. You're usually having legacy systems, legacy software, aside from doing DevOps practices.
Yeah, I see. As far as I'm aware, this legacy word has actually become something part of the intellectuality of a software. So when we say legacy, it means not following DevOps practices. Am I right in here? Or
to some extent, yeah, because if you were to... DevOps in itself is a very recent term. It's been there for the past 10, 20 years only. It's not something that came with the start of the initial computer science kind of, let's say, revolution. Exactly. Yeah. So it's pretty recent, and if you keep up with the practices, that means you are at the cutting edge, right? Because every day something comes out, a new practice, not to just let's say deploying software or making things autonomous, but also to writing software. The practice is not only about, let's say, the planning phase, the deployment phase, or the operation phase. It's also about how you develop software. So it also applies there. And if you apply those practices, you are usually on the right path.
I see. And now as we proceed in the discussion, we understand that legacy is not initially bad or
no, definitely not
irrelevant, but it's the way that organizations are shaped and the way the projects that they work on. So it's always very clear that when we say DevOps, people look for a specific person with DevOps title, which to an extent I believe it's not very, very true to define it this way.
Definitely not.
Let's talk about team structures. How team structures need to be changed, need to be adapted in order for an organization adapt and work on DevOps practices.
Yeah. So the DevOps term itself is not. I mean, you make it easier for people to understand to just say, here are my DevOps team. Really, they're the people usually taking care of the server administrations, the automation system, and so on and so forth. But really, there isn't such a thing as a DevOps team. The DevOps, the term itself, is making sure dev and operations are coming together, so they are not so far away, right? You want to make sure the distance between these two teams is lessened. So the team structure usually means if you have 10 developers, those 10 developers should actually be able to deploy their own software, to write automations, write let's say automated tests, write all of these different kind of autonomous scripts to make their own lives easier. And if you have such talent in your team, you're already kind of a DevOps team, right? Because you're doing development and you're also doing operations. It all comes down to the developer's talent, not the different teams. Let's say if the developer has the talent, has the expertise and skill sets to apply those practices from the get-go, then your team is practicing DevOps.
Yeah, I see. So what you're saying is that it's possible for someone to be a developer and DevOps kind of
definitely
at the same time.
As I said, the differentiation of a DevOps team is really just to make it easier for people to understand what you're doing. Other than that, all the DevOps members here, or the people working on those, are actually developers. They actually write day-to-day software. They write client applications. They write backend applications, and they have a preferred stack, let's say, but it's just that they have a skill set that they can apply such practices to that software and help the team grow a little bit easier.
I see. Yeah. That's very clear. So you're telling me that there's no one person that only their job is DevOps, right?
Not in my dictionary. I always say you have to be a great developer to become, to apply those practices, because it requires a little bit different understanding of how to get things done. You require a little bit of network knowledge. You require a little bit of automation. You require a little bit of scripting. You need to get a little bit of pieces from different stacks together in order to apply those practices.
Yeah, thank you very much. So we cannot talk about the transformation of an organization unless we know why you want to transform, right?
Yeah.
So I really want to start talking about advantages and disadvantages of specific kind of methodology. But let's start from legacy. What are the disadvantages of a legacy-based system? How would legacy-based system is not functioning to its optimal level in a specific circumstance?
So that's a little bit hard to explain, because legacy in itself could mean a lot of different things. It could mean legacy hardware. It could mean legacy stacks. It could mean, older versions of more recent stacks. So when we are talking about legacy, we have to define what we are talking about. So for example, let's imagine an organization that is building software for some clients, and that software in itself, if it's kept up to date and if it's always making sure that there are security patches, you make sure you are on the latest stack, you make sure when upgrades come in, you do that regularly. That in itself means you're not a legacy-based system, right? Because you are up to date with technology. But let's come to, let's say, the deployment part of things. If you have a person in your team that logs into a server or just pushes the code to a server, downloads it on that server, restarts the application in order for the service to be updated, that in itself is a legacy way of rolling out new versions. What you could fix in that would be to make sure that part where you build that application, where you test it and deploy it, is automated properly through your let's say your CI environment. So that, for example, if you're on GitHub or you're on GitLab, you make sure that you have an action. Once a developer pushes code, that code that is currently pushed is automatically tested, built, and deployed to the server instead of a person doing that.
Yeah, so I think you've created an image in my head, like DevOps practices is kind of an extension of CI/CD pipeline, right? So it would be something like as CI/CD continues, at the end of it, it would be DevOps practices, how you automate things. Am I right in here?
Not really. So maybe we can rephrase that together. Okay, let's get back a little bit.
Yeah.
So DevOps practices, one of practices of DevOps is basically, that CI/CD pipelines we were talking about. That's a practice in itself.
Nice.
It's not like at the end of this CI/CD you get some DevOps practice.
Yeah.
That building pipelines, that in itself is a DevOps practice because you automate things. As we mentioned before, the idea is to automate things, to make things more basically less human work.
I believe that there is a terminology that, correct me if I'm wrong in here. So the pipeline for version controlling, it starts from a developer and ends with deployment. Is it how DevOps looks at
usually
it?
That's the case where a developer from his laptop or her laptop makes some code changes, commits that, pushes it to a repository, and in that repository, usually there's something watching changes. So whenever a code change happens, there's a runner or some kind of script that runs. It makes sure that first your code is tested, and once the tests are complete, you build a deployable package, and that could be a Docker image, it could be a zip file, whatever deployment method you're using. And once that is done, when that package is ready, you push that somewhere. You usually push that package to either a server, Kubernetes environment, the cloud. You push it somewhere, and those three steps together are the CI and continuous integration and continuous deployment, where the developer just needs to push code, and that code is automatically up on the, let's say, on the server.
Yeah, thank you very much. And now I have a very clear picture how the actual things happen. And I'm not sure, but I want to ask you here, is that script which is written in the pipeline, is it in a specific programming language, or it's up to you how you write
It's usually around these days that you have many options. You have GitHub Actions, you have GitLab CI, you have Jenkins, lots of different tools. We are mainly at DIT, we're mainly using GitHub Actions, and we also have our own custom runners where we do specific things on them. But you could write in Bash, you could write in Python. Really, your choices are open. You can write it in whatever language you prefer.
Clear. And if something goes wrong, the actual code is not going to be deployed. It would be prompted with an error, but the application still works, right?
Yeah, definitely. So there's a little bit of a bigger picture to these things usually. It is correct that, we're talking about test as build and deploy, but that also means your code has to be testable. You have to have written automated tests for that software. Because if you have not written any tests, then really what are you testing, right? So that's why we mentioned DevOps practices in also software development, is to make sure your code is, testable in the most basic sense. And once you do that, then you build a Docker image, you build a deployable package, and then you deploy it. Then that's the whole, let's say, CI/CD pipeline.
Yeah. Thank you very much. So now we understand that technicality. Thank you very much. You explained those complicated technical topics in simple language. As far as I'm aware, it cannot be simpler than this because it's purely technical in itself. Let's talk about some projects that you in here in the IT have used DevOps practices. And if you could demonstrate to us some projects, it would be very clear for us if you talk about a specific project that you have not used DevOps practices and you used it. Yeah. What changed? What changed in terms of results of the performance? So
it's a little bit. When I first started DIT, there weren't many. It was just like any other organization here in Kurdistan. The developers were tasked with deploying the code manually onto a server, restarting that server, and making sure that things are up and running. So when I first joined when I first joined the IT, the project that at the time that was being worked on was the border control system, and we had previously the team had previously built KFMS, which at the time actually had a different name, but it was later renamed to KFMS. So KFMS as a system itself was deployed using, let's say, the legacy kind of the manual way of deploying software. And as the team
Could you describe the manual? How was it exactly?
Yeah, so basically a developer who was working mainly on the application would package that application and SSH into that server, pull that package or download that package into the server, restart the servers, and put the new code up. That's how it usually was.
I have done that previously.
Exactly, we've all done that. We come from a little bit older times. That's what we usually used to do. But that had a lot of disadvantages. One of them would be that developer needed to be there, right? If that person was not there or did not have direct access to that server, there was no deployment. If that person was not available, then good luck deploying that service. So it has also a lot of different.
So we had a server guy, right?
Yeah, exactly. It's not a server guy even. It was the person developing the software was actually doing that. Kudos to him, by the way, for doing that at the time. But you imagine the amount of pressure that person has to log into a production server and apply new changes, because there's no easy rollback. There is nothing. If the system goes down, that is a production system going down.
That's true.
So at the time, as I said, we were working on. The team was working on BC, the border control system, and we started preparing our Kubernetes clusters. We started preparing CI/CD pipelines to make sure things are automatically built, deployed onto that cluster. And that is when we started creating our dev, staging, and production environments. And we were in the very early stages of figuring out how we wanted to do things. Because for example, in our CI/CD pipelines, there's different ways to do things. There's the push model, there's a pull model, and there's different kinds of way of doing things. And what we initially did was the push model, where developers used to push code from their source from their laptop. It would get built on a runner. It would be tested, get built, and once the package was ready from that runner, let's say the package was deployed onto the Kubernetes cluster. Whereas what we are utilizing right now is the pull model. Is instead of once the image is prepared, once the Docker image is built, let's say on that runner, it's no longer that the runner contacts the Kubernetes cluster for that deployment to happen. It's the other way around. The Kubernetes cluster pulls that information, and that makes sure it makes things easier, and it really shows how over the span of 3-4 years we've improved also in applying the practices. Because before, if we wanted to change a simple load balancer configuration, we had to wait for the whole software lifecycle for testing, building, deploying again to happen for a small configuration change. Whereas now that configuration change has nothing to do with the software itself. It's a different, part of that whole ecosystem, and that applied instantaneously after tests, of course. So it also, that you also see a lot of progress over the years of how we apply these different practices. So we started with that. We started with BCS, and we made sure that it is automatic. It's autonomous, fully autonomous. Developers push their code, everything is up, and it was a relief for the developers to not actually have to push code to any server. They don't have to do any kind of manual work in that regard. And once that project was stable enough on the DevOps side, the developers were still working on it. They were still releasing new versions every day, multiple times a day, actually. That's when we started looking at KFMS and making sure we bring that into the way of working. And it actually, now I remember things when I'm talking about it. We had a lot of challenges because before, the system was on a single server. The files stored on that application was actually stored on the disk, and the database was also on that same server. So this is not usually what you would do in a more modern stack. You would have your database separate, you would have your file storage separate, you would have your application separate. So we started working with the developers to make sure that we needed some maintenance window, definitely, because this was a big change. We needed to bring that whole thing back in. We needed to split things first of all. So the first thing we looked at was the disk, and it had a lot of files on it. So we wrote a script to upload all of those files to an external storage, and we started taking a backup of the database, restored it on a different machine, on a different database cluster, and then all was left was the application. And we had worked on previously on packaging this application as a Docker container. It was initially still a monolith, so it was not it was no microservices architecture or anything. It was just a monolith in a Docker container. So we built that image, brought it back onto Kubernetes, and everything was working very nicely. The developers, when they were pushing code, it was a relief for them to not have to go on the server, pull the new code, restart the server. It's just nice to see their lives are a little bit easier now, and they can focus on what matters most.
Yeah, I totally understand that challenge,
Yeah.
and I have been through it myself. As we've talked previously about other projects, I've personally been a software developer. I have done the same exact thing. You go to the server, you download the last version because you've lost of track what versions that you have. Then you make the changes and then you re-upload.
Yeah.
And anything goes wrong in between, good luck.
Yeah. Hopefully this is no longer the case, because when you are on Kubernetes and you're on newer tech stacks, these things are usually easier. If you have to roll back to a previous version, you can do that very easily with a git command. You push, you can do that, and everything. Load balancing is much more easier. High availability is more easier. Scalability is easier. These things, we usually take it for granted here at DIT because we are trying to do things by the book so much that we forget these are actual problems people are facing outside, right? Because it's no longer the case where we think about load balancing because we have figured that part out. We have solved it, and we focus on the software part. Same goes for high availability. If a system unless a critical outage happens, we do not have the case where we say, the system is not available because you have multiple instances of that software running on different nodes in that Kubernetes cluster across availability zones. So, these things we take for granted, and as we talk about it, it's nice to take some time to appreciate what the teams have done here, and it finally pays off doing things by the book.
Yeah, that's true. That's very much true. So the last part of our discussion would be about a project that almost everyone is aware of, and it's something that I believe DIT is intensely working on. And as far as I'm aware, DIT is very proud of taking part of this in this project. It's my account project.
Yeah.
I'm pretty sure almost everyone knows how many beneficiaries would be benefited from this system, and the tech infrastructure definitely needs to be so kind of strong
in
order
to be solid.
to handle those kind of data. Yeah, talk to us a little bit about the experience of including DevOps practices in my account project.
So my account was a very special project for us because it came at a time where it was, we figured out it's actually the project's goals align with the my account project. Came at a very let's say it was a very intensive project for us. It was the timeline for it to be in production was insanely little for us. It was only 3 months from the start of development to deploying it into production. And I used to say that no app would take less than 3 months. Even a simple to-do app that you do for yourself takes at least 3 months. But my account, the team working on my account actually were they proved myself wrong, where they developed the system in such quality time, in such manner where it was done by then. And our main task is on my account was making sure that the system was highly available and scalable, because a lot of agents a lot of concurrent agents are using the system, and we want to make sure that they don't get they don't get disruptions, so that people do not have to wait for their registrations to. It shouldn't take a long time for you to register. and we made sure that the systems are highly available. We did a lot. One thing that was different about my account was the use of GPUs because there's some machine learning happening, and we made sure that there are some GPUs available for that system to utilize. And that was one of the challenges that we faced because we had not done such a thing on Kubernetes before. But we did that for my account. And we made sure that we have enough compute space. We made sure we have enough storage space for that project to be successful without a disruption. And thankfully, it has been the case.
Yeah, amazing. The real implementation and the real usage on day-to-day proves that this project has been developed on a very solid and strong foundation.
Exactly, because the project's timeline was so short. It was very important for the teams to make changes very frequently, and especially in the first few weeks of when it went into a pilot stage. The teams were able to deploy releases like 10 times a day, and you cannot do this if you do not have proper infrastructure, if you don't have proper pipelines in place. If people required UI to change, they wanted logic to change, and they wanted to do that fast. And if we were not practicing these ways of working, it would be very hard to actually, you would have to wait at least a week or 2 weeks for a change to be implemented, to be tested, to be deployed later on. But throughout the years, we've gained a lot of experience, and it really paid off in this project to deliver it in such a short time.
That's true. Yeah. Very, very brilliant. Huge shout out to everyone who's involved in this.
Thank you very much.
Yeah, my very last question would be something kind of a little bit personal to you.
Okay.
What advices or what suggestions do you have for organizations that are developing software? How would you encourage them to have a good eye on DevOps practices?
This was our main podcast, let's say
theme.
Yeah. That's what we wanted to talk about. We didn't get into too much depth in there, but yes. I highly encourage organizations and companies working in the tech area to invest more in their developers. It is not also for developers themselves. They need to know that these practices that they apply, these new tech skills and these experiences that they can gain from following these practices actually very beneficial for themselves. They would become more autonomous. Nobody would call you at 2 a.m. asking you to deploy a new version because that part is automated. You could have made the change and then you could have scheduled a release to happen at a certain time. You make sure when you make changes to your code, if you have proper tests and test runners in place, you wouldn't be worried that you broke something while coding. And utilizing things like Docker and containers, Kubernetes, you make sure that you are compatible with a lot of people out there. Like, imagine if you wanted to deploy a software on someone else's hardware, you wouldn't need to know the hardware specification. You wouldn't need to know about the OS layer. If you have a proper Docker image, you can run it anywhere. So I highly encourage developers to go ahead and look at what Docker is, what containers are, what is Kubernetes, what is automation, CI/CD pipelines. All of these different terms are usually a little bit unknown to local developers because they are focusing on one part, which is writing the software in itself, and they forget how important it is to make sure you are on the on latest technology.
Yeah, thank you very much. Very, very brilliant. I'm pretty sure that anyone who has listened to those advices would definitely be encouraged to at least have a look at this and get to know more about these very important topics. Thank you very much, Shkar, for being with us today. I really enjoyed the discussion.
Likewise.
And thank you very much for staying with us to this point. This is going to bring us to the end of this episode of Digital Transformation Podcast from the IT. Until the next time, have a nice time.